So there's a couple more angles that you really need to know after you do the ones with the special triangles, which are called your quadrantal angles. And these are the ones that hit the quadrants, right? So the x-axis, y-axis, negative x-axis, negative y-axis. So what we're going to look at is how do you determine the exact function value of these quadrantal angles for sine, cosine, and tan. The first thing that we have to remember is that when you're looking at sine, so if we were to draw angle theta in here, if you've been really focused on opposite, hypotenuse, and adjacent, it doesn't work for quadrantal angles, because if you look at where the quadrantal angle is, it's actually on the x-axis. So the triangle made with the x-axis is just a flat line, and so you can't think of it as opposite, adjacent, and hypotenuse. Instead, what you have to think of again is the opposite is your y, the hypotenuse is your radius, and the adjacent is your x. So let's just take a second right now and just write those ratios. So if you're finding the sine of theta, it's going to be y over r. If you're doing the cos of theta, it's going to be x over r, and then the tan of theta will be y over x. So then the next thing we have to do is look at what are the lengths of the x, the y, and the r for these quadrantal angles. And so we're going to think of these all as unit circles, meaning that the radius is 1, which means when you hit the x-axis, you hit at 1, 0. When you hit the y-axis, you hit at 0, 1. When you hit the negative x-axis, you hit at negative 1, 0. And when you hit the negative y-axis, you hit at 0, negative 1. So that the x value for the angle of 0 would be 1, the y value would be 0, and then the radius is always 1. For the 90-degree angle, the x value is 0, the y value is 1, and the radius is always 1. I'm going to leave these bottom 3 for you to do, and I'm just going to continue filling out these columns, and then I want you to pause the video and try these 3. So then when you're looking at the sine of 0 degrees, it's y over r, which is 0. For cos, it's x over r, which is 1. For tan of 0, it would be y over x, which is 0. If we're looking at the sine of 90 degrees, it's y over r, so 1 over 1, which is 1. For cos of 90, it would be x over r, which would be 0. And then for tan, it would be y over x, which would be undefined, which means does not exist. So now what I'd like you to do is pause the video and then fill out these 3 columns the same way that I did these 2. And then I want to see if you could figure out a pattern. So I'll just keep filling these out. So negative 1, 0, 1, 0 over 1 is 0. Negative 1 over 1 is negative 1, and then 0 over negative 1 is 0. And then here we've got 0, negative 1, 1. So this would be negative 1 over 1 is negative 1. This would be 0 over 1 is 0. And then this would be negative 1 over 0, which is, undefined again. And then lastly, this guy would be 1, 0, 1. It's the exact same as 0 degrees. So 0 degrees and 360 are coterminal. You don't really need the 360, but I just thought I'd throw it in there just so that you get that full circle picture. But it's going to be 0, 1, 0 as well. So when you're looking at this, we're going to use this again when we start graphing these functions. But you'll notice that sine goes 0, 1, 0, negative 1, 0. Whereas sine or cosine goes 1, 0, negative 1, 0, 1. So they're very similar. They're actually off by 90 degrees. And then you'd have the exact same. So if you shifted this guy by 90 degrees and started it at 0, then you'd go 0, 1, 0, negative 1, 0. But instead, sine starts at 0 and goes 1, 0, negative 1, 0. And cosine starts at 1 and goes 0, negative 1, 0, 1. That'll mean a lot more when we do the graphing section. And tan just goes 0, undefined, 0, undefined, 0. So now you're going to be asked to find the reference angle, if possible. These ones aren't going to have reference angles, and the exact function value if it exists. So these questions are lumped in with the special triangle questions, but I separated them out just so that you could get them really clearly. So if I asked you to find the cos of 180 degrees, you're not going to have this chart. What I want you to be able to do is, first of all, draw 180 degrees, which is going to be here. Label that point, so it's going to be -1, 0. Radius is always 1. And then you're going to figure out cos. Cos is x over r. So it's the x value of -1 over the radius of 1. So the cos of 180 is -1. Next one would be tan of 90, -90. So the first thing you're going to do is draw it. So -90 is down here. And then again, label that point, 0, -1, with a radius of 1. Tan is y over x. This is something that I would recommend writing on your formula sheet. You know, if there's somewhere where it says tan theta equals opposite over adjacent, put equals y over x as well, because this is the one people tend to forget. So then the y value is -1, the radius is 1, so the tan of -90 would be -1. And then sine of 720, if you don't know where 720 is, what you're going to want to do anytime an angle is bigger than 360, you have to find a coterminal angle. So you're going to start subtracting 360. And what you'll notice is that as soon as you do 720 minus 360, you get 360 degrees. So the sine of 720 is the same as finding the sine of 360 degrees, which again, you would draw here, you would label your point, a little bit neater than that. And then sine is y over r, which is 0 over 1, which is 0. Awesome.